Welcome everybody to this session, and I'm really pleased to say that we have Professor Daniela Schmidt here, who's going to present around the IPCC processes, and particularly about the process that she was involved with as the coordinating lead author for the Europe chapter in Working Group 2. So as many of you will be aware, the IPCC is the body that produces the definitive evidence around climate change, the impacts of climate change, the drivers of climate change. And so it is incredibly important in terms of charting out what the world needs to do in the future, both to mitigate the risks from climate change and to reduce greenhouse gas emissions. It's a huge undertaking. I mean, just Working Group 2, I mean, there were 270 authors, 60 from 67 countries. There were more than 62,000 reviewer comments, which makes most peer review processes pale into insignificance. The report has 18 chapters as well as 7 cross-chapter papers. And as I said, Dani's role was as the coordinating lead author for Chapter 13 on the assessment for Europe. What Dani will present on today will be a mixture of the key messages that came out for the summary for policymakers, but then also some of the key findings from the Working Group 2 paper itself. This is one of a number of presentations that Dani has made to lots of different audiences, but it's really great that we're having this opportunity internally. So one last thing just before I hand over to Dani, she will make a presentation for about 30 minutes and then we will have a Q&A session. Given the numbers of people on the call, could I ask you to type your questions into the chat box so that I can monitor that and then I can put those questions to Dani. Could I also emphasize that what Dani is going to answer questions on are issues related to the IPCC report, but she will not be answering questions beyond that. So this presentation is on the IPCC, so please structure your questions around that. If you have wider questions, well, maybe that's one to put to Dani on another occasion, but not today. So with that, I'm going to pass over to Dani, and the floor is yours.
Thank you very much. So the IPCC process has summarized 34,000 papers which have come out since the last assessment cycle, which finished in 2014. I will focus this on the key messages around the report. Working Group 2 focuses on impacts, adaptation, and vulnerability. And when it comes to vulnerability, it's both vulnerability from climate change, but also vulnerability to climate change. And I'll come back to that when I report of the key findings there. The main statement is the science is clear. Any further delay in concerted global action will miss a brief and rapidly closing window to secure a livable future. What didn't come really out in the media work over the last 2 weeks, and let's ignore the geopolitical background, is that the report offers solution. It's not a doom and gloom. It is, we can adapt, these are pathways, and this is what climate resilient development looks like. And it's really important for me that this is the message which comes out of this report. The whole report has 3,500 pages. So, you know, every one of you, depending on your backgrounds, and it can be cities, it can be ecosystems, it can be water, will find a chapter dedicated to that, as well as the regions where you work, which is still very rich and intense. We then boil this down to a technical summary and a summary for policymakers, where I jointly with Elizabeth Gilmer from Canada, who's an economist, led section B, which is on observed impacts and projected risks. So what's new when you compare it to AR5? One of the main points is the strong understanding of the interconnections of peoples, regions, and human society and ecosystems and biodiversity. The way we impact each other the space for conservation and restoration impacts ecosystem service and livelihoods. And climate change cannot be seen as an individual problem. It comes together with unsustainable use of natural resources, with habitat destruction, growing urbanization, and inequity across the world. It is really important to understand that a huge number of people on this planet today, and the estimates are between 3.3 and 3.6 billion people, live in hotspots of high vulnerability to climate change. They face a wide range of challenges, such as limited access to water and sanitation, health services. They often have climate-sensitive livelihoods, directly dependent on the land they live on. They have high level of poverty, and often weak leadership, lack of funding, and lack of trust and accountability in the governance systems they are living in. One of the other key messages of the report is that those risks which people are facing are becoming more and more complex. While we might consider compounding hazards, such as the joint impacts of heat and drought, we also need to consider the compound impacts and risks developing from those. Here's an example around heat and drought in agriculture. It's not just impacting the crops and therefore resulting in reduced crop yields, but it's also impacting the farm workers because of the heat stress to them. They are often paid per hour, and therefore reduced productivity has impacts on reduced household incomes, while at the same time food prices are rising. And so what the report is very strongly emphasizing is those compounding and cascading risks through systems. It talks also very strongly, and that's also drawn on the collaboration with IPBES over the last years, on the crucial importance of nature and nature services, which are at risk in a warming world. These are just listing a few, but I think it's really important to think about the wide range of ecosystem services we so strongly depend on. Pollination is very much at the forefront of discussion, coastal protection, food sources make sense, but it's also income for people via tourism. It is the climate regulation, the clean air, the water filtration, and the report very strongly emphasizes the growing evidence for impacts on mental health and the importance of green and blue spaces for alleviating some of those mental health questions. So what are the increasing risks look like? What you can see here on your left-hand side is our handshake from the Working Group 1, which last August published their report on the physical basis, where you can see from the 1950s to 2100, the warming projections under different economic, population growth, and emission scenarios. Our responsibility then is to assess what the impacts and the risks are, assuming low or no adaptation in this case. What you can see are the burning embers, the classical IPCC colors going from yellow, which is moderate risks, which you can see have already materialized at our current warming, which is indicated here by the gray line, which is 1.09 degrees. And then those risks increase into red high to purple very high. The reasons for concern are done every year, and they're here on unique and threatened systems, extreme weather events, the distribution of impacts across the globe, the aggregates of those impacts, and large-scale singular events. And because they were done in the last assessment as well, we could compare our understanding of those risks. And the key message is that all of those risks are now projected to materialize much earlier at lower warming levels than previously assumed. Some of those risks will materialize in the near term. And so increasing climate hazards result in irreversible impacts, with the most vulnerable are the natural systems where autonomous adaptation will reach its limits, in polar ecosystems, in tropical coral reefs, in coastal wetlands as examples. And the report brings many more of those in the relevant chapters. These risks will increase with increasing warming. And so the main risks which we wanted to point out here is heat stress. So the exposure to heat waves will continue and will increase with additional warming. water scarcity, especially in regions which depend on the cryosphere, on glaciers and snowmelt, which will see a strong decline in water availability, the resulting impacts on food security of both from heat and water scarcity, and the impact that would have on food security, as well as flood risks, both along rivers and coasts, and thereby impacting low-lying cities, which have their own cross-chapter paper, and small islands, again, an entire chapter assessment. The report points out that adaptation is happening, but the progress is very uneven. There's a lot of reports on adaptation with regards to water, as both water availability as well as flooding, but it's not happening across the sectors and it's not happening fast enough. For water management, the largest amount of literature available talks about irrigation, rainwater storage and water saving technology, moisture conservation in soil. And many of those approaches have economic and ecological benefits and reduce vulnerability. They also help secure drinking water with floods and drought risk management and considering working with nature in a land use planning. But there also is a really strong risk in our increasing dependency on water as the effectiveness declines with increasing warming. And therefore, using irrigation will result in past dependencies of the water users for agriculture when we also need it for people, for cities, and for other adaptation options. The water management is really important for our food security at the moment, though. Other options are improving cultivars, when we plant, what we plant, when we harvest. There's a huge emphasis on agroforestry and agroecology, so the intermingling of food production with forests, with trees, with landscape planning, and landscape diversification. All of those adaptation options, of course, are place dependent, and so community-based adaptation is fundamental to the success of those. And if they strengthen biodiversity, then it's a wider range of sustainable development goals. These can be reducing food security, can improve food security and nutrition, because it's also very clear that when crops fail, malnutrition is increasing, thereby, of course, have positive impacts on health and well-being and on livelihoods. A strong emphasis in the report is also on cities, transforming cities. It's important to think about that by 2050, 2/3 of the world population is projected to be living in cities. And these cities need to adapt. There is a lot of emphasis on nature-based engineering approaches coming together. And you can see here the green spaces on the roofs. But at the same time, we need to consider that these have impacts on the neighborhoods where they are established. Urban agriculture is mentioned, but also really the importance of safety nets, because disasters will happen, climate change risks will materialize, and so a coherent network for disaster risk mitigation. The wider benefits of some of those adaptation options are public health improvements and ecosystem conservation. But maladaptation is something which we already see clear evidence of. This is just one example. There's an entire section in the summary for policymakers on maladaptation. The unintended consequences of some of our adaptation options, for example, can lead to settlements in areas which are currently, with the existing adaptation options, safe from flooding, but might not be in 20, 30, 40 years' time. We also, by planting, by putting those engineering solutions into our coastal systems, we might reduce the space for nature, for wetlands to absorb some of the water and thereby aggravate the risk. And it's important to recognize that the most disadvantaged groups are also most affected by maladaptation. Even with all the adaptation options we list, it's really important to consider that even the most effective adaptation cannot prevent all losses and damages. We will see hard limits to adaptation. Above 1.5 degrees, some of our natural adaptation solutions might no longer work because certain plants might not have enough water at a given place, and our wetlands are exposed to increasing sea level rise. Similarly, above 1.5, the lack of fresh water could mean that people living on small islands and those dependent on glaciers and snowmelt can no longer adapt. By 2 degrees, there are projections that we have multiple concurrent failures for really important staples such as maize and wheat. So what is our future going to look like? And I think it's really important that there's as much space in the report for climate resilient development as there is for the risks. Climate resilient development is considering adaptation, mitigation, biodiversity, and the sustainable development goals at the same time. Thereby, it's reducing vulnerability, it's reducing poverty, ecosystem degradation, but it's also really important to consider that it's just. And equity and justice are fundamental parts of this report. Any solution frameworks will have to be considered across levels of governments and civil society, because solutions are place dependent but need to be facilitated by international and national agreements. They involve everyone by forming partnerships so that voices are heard and adaptation options will be supported by the local communities. They will conserve and restore ecosystems so that they can support humans. And they will involve marginalized groups by prioritizing equity and justice. It's really important to consider that this will require upscaled investment. The report doesn't talk about how much it is because the economic numbers are really highly variable amongst the studies. But what it clearly states is that at the moment of the adaptation finance, around 80% goes to mitigation and not enough for adaptation, despite the fact that we'll need it. Climate resilient development is already challenging today. Doing this at 1.5 or 2 degrees might become increasingly difficult. So this is the end of the summary for policymakers, the most bizarre thing any academic can be involved in. So it was us and the representatives of 195 United nations with up to 40 delegates per nation, where every sentence is read out and gavelled down. That's the gavel you can see here. I've never discussed one sentence for 6 hours before. But I also wanted to show you parts of the Europe assessment so that we can see a little bit more what climate change might mean to us. What you can see here, firstly, are the hazard projections. We have maps for extreme heat overlain by population density, where, as you would expect, the largest heat, of course, in the southern region, and less the heat's defined as days above 35 degrees, less in the north. The maximum one-day rainfall or precipitation, because it could be snow, with a much more patchy patterns. And the summary of our assessment is that we can already see impacts on systems, both natural and human systems in Europe. These impacts vary strongly across regions in Europe and across sectors and societal groups, and thereby deepening the inequalities we already have. These are not just land, but we also have an assessment, as you can see here, on the ocean-driven hazards. We have sea surface temperature changes and mean sea level rise projections. And similarly, these are unevenly distributed. We have, as a group, as an expert solicitation with other contributing authors, done an assessment of what the key risks are for Europe. And they are very much the same as globally. We see human heat stress, mortality and morbidity, the impact of heat on terrestrial and marine ecosystems, the impacts of heat and drought on crop production. And they will increase number of deaths. They will decrease suitable habitat space for ecosystems, and they're projected to lead to substantial agricultural losses. Again, you can see that these burning embers, they're done the same way as the global ones, are materializing at different temperatures. But for several of those, there is already medium risk at our current temperatures. Key risk 3 assesses the water scarcity, highlighting the regional differences. So the leftmost one is for Southern Europe, the one next to it for Western and Central Europe. The UK is part of Northern Europe in this assessment. And then key risk 4 looks at flooding, pluvial flooding and river flooding, coastal flooding, and the impact it has on long living infrastructure as well as our coastal heritage. And the risk for water scarcity will become high first in Southern Europe, but also subsequently in Western Central Europe. And the risk for sea level rise, which we have assessed for beyond 2100, is a severe risk to infrastructure, as is the risk of riverine and fluvial flooding. But similar to the global assessment, I'd like to introduce you to some of the adaptation options, because we have many options in these regions, and because financially we are under much more able to invest, as well as we have some lower risk than other regions on the planet. So for heat stress, so what we've done for all of those is we've done assessments of the distribution of the risks, which you can see here. This is the projected heat stress for people. It's the midterm 2040 to 2060. Blue is the lower end of the risk deciles. Red is the higher end under different SSP scenarios. And what you can see is very much what you would expect. Higher warming will impact people, but will impact people again with a geographic distribution difference in both Eastern Europe as well as in Southern Europe. But what we wanted to do then is to go a step further. And so what we have done is quite complex pathways of adaptation and feasibility and effectiveness assessments. And I'll show you some of those for the different sectors. We have done them for most where we were able to based on the literature, if you're looking at the entire chapter. So again, that's the same burning ember. This is now concentrating on human health. And what you can see here is for Northern Europe and for Southern Europe, under low, medium, and high global warming, what those health action plans might look like, which reduce risk. What you can see then is how long we think these can be used, how long they are effective being used individually, and when they need to be combined. And in the differences between the region, when also how quickly they can be implemented. And it's clear that Southern Europe is much more prepared for heat than, for example, Northern Europe, because of behavioral changes of people, because of housing structures. And so measures are to be implemented, combined early in Southern Europe, but there are already many of those available, such as heat proofing, air conditioning, building interventions, and the behavioral changes. I will not go into detail on any of those, but I really encourage you to read our assessments on each of those. What we have also done is, I've done impact and risk assessment for a large number of systems. This is the example for terrestrial ecosystems, but you could find these for most of the systems we've looked at, where we have observed in the top, projected at 1.5 degrees in the next row, and then projected at 3 degrees for our regions. So Europe is for the entire Southern Europe, Western and Central Europe, Eastern Europe, and Northern Europe. What you can see, the color gives you the confidence level for the observations and the projections. And what you can see very clearly is that impacts are already visible for many of those risks which we've looked at. Changes in phenology are detected amongst so many groups, range shifts, reduction in biodiversity and habitat availability. What we don't have for ecosystems is those adaptation pathways, because we do not have enough literature to be able to do that. But we have projections, again, showing regional differences. What you can see here is a way of assessing the risk of extinction by looking at suitable climate conditions in Europe. What you can see here is the fractional niche remaining, with green very high and the red and purple arrows very, very low. For plants on your left, insects in the middle, and mammals on the right, at 1.5 and 3.2 degrees Celsius. And you can see the real risk warming above 1.5 is posing for several of those groups of organisms. And of course, the services, if you're thinking of plants and insects, these provide. Additional to that, the report really emphasizes that fragmented, polluted, overexploited ecosystems are much more vulnerable to climate change. And so there's a real call out for conservation. But conservation needs to be coordinated and needs to have stewardship. This is an example here from the European marine protected areas. We have 3 seas we've looked at. So that's the Southern European seas, the transitional seas, and the Northern European seas. And what you can see here is the total area indicated by the big box on your left-hand side. The darker blue are implemented and partially protected marine protected areas. The very dark ones are implemented and no-take. And it's evidently clear from this figure that we have some area in Europe implemented as marine protected areas, but the protection is completely unknown. And therefore, adaptation actions such as habitat restoration and protection might be completely useless. While we know that they, and on land, fire and forest management and agroecology can increase the resilience. So we really need to consider how we support nature to support us. We've looked at a large number, sorry, that has gone the wrong way. I'll show you this. We've looked at food production and crops. And what you can see here is the thinking of what we can do and how much it will reduce risks. You can see maize at the top and you can see wheat at the bottom. For wheat, with Russia and Ukraine, part of our assessment, that is 30% of the world's wheat export. And you can see the yield changes on the left-hand side under current production systems, where you already see severe impacts in several parts of Europe. The next row then looks at the next column at increases with increasing irrigation, and then combined with new varieties. But what that masks is that the water demand for irrigation will dramatically increase, especially as you can see here in the Mediterranean countries, where water is already scarce. And so while we can reduce some of the yield losses, which are projected, especially in Southern Europe, and with irrigation and changing variants, this ability will decrease dramatically, and it will make us extremely dependent on water availability. For flood risks, we have a huge amount of information on systems which work. And so we have generated tables like this, which look at the various impacts types, river flooding, coastal flooding, pluvial flooding, and this is water in totality, so it's water scarcity as well, with a number of its adaptation options, and have assessed, based on the literature, if these measures are effective, but also if they're feasible, if they're economically feasible, if they can be technologically implemented, if they are institutionally supported by our governance, their impact on ecology, but also if they are socioculturally accepted. And so for water, we have early warning systems. We have water and ecosystem-based adaptation and sediment accumulation, engineering-based options, land use management, but also we're discussing managed retreat. And we are trying to do this for all of the main key sectors, so that those pathways we have generated are really a narrative of those different options for supply and demand in this case, but also showing very highly that under high warming, all of that has to come together and will not be sufficient to reduce risk. When it comes to water, it's also really important to consider how much of what we consume has virtual water flows embedded in them. So this is seeing us in an international map for a number of staple products. So this is soy, coffee, cocoa, palm oil, and lots of others. And what it shows is that many climate risks emerge as a combination of us in the supply chain. And we saw last year when that ship was blocked in the Suez Canal, how much of what we consume is imported. And so there's indication that, it can destabilize financial markets and of course, food production and marine food sources beyond our own region. I would like to end on the last wish, which is the sea level rise. And I'd like to end on it because here we were able to go past 2100. At the moment, the IPCC is still very much focusing on 2100, but the IPCC has been doing this for 30 years, never extending its temporal remit. And it's interesting to have a look at the sea level question because, as we all know, we have committed to a certain amount of sea level rise because of the global warming we already have. And we want to show here in this figure, which is quite complex, it shows both the planning for how many meters of sea level rise by the end of the century or mid-century, as well as the number of people exposed and the differences for that for the different parts of Europe, where some countries, and I don't want to point out individual countries because that's not our responsibility, have very, very high number of people exposed, but don't plan for a huge amount of sea level rise. And so coastal flood damage is at the moment projected to increase, but at least tenfold by the end of the century, and even more if we're not increasing our adaptation and mitigation. So climate resilient development shows that while adaptation is happening in Europe, it's not at the scale, depth, and speed to avoid risks. That our existing and our planned adaptation measures are not sufficient to avoid residual risks. And these will result in loss of habitats and ecosystem services, heat-related deaths, as we have already seen in the heat waves we've had over the last decade, crop failures, water rationing, and ultimately loss of land. If warming were to go over 3 degrees, a combination of many, possibly all adaptations will be needed and still not sufficient. And that we really need to consider windows of opportunities, such as budget cycles when funding is invested, political reforms and policy changes, infrastructure investment cycles of sewage system, but also things like the COVID recovery program, the net zero investments, and make sure that climate change adaptation is the heart of each of those decisions. Ultimately, it's important to remember that every action reduces risks, but time is running out because fewer and fewer actions are available if the planet is warming beyond 1.5. It's also important, and I like to end on that every voice matters. There's no point in taking an adaptation option which worked at one place and installing it in another place without knowing if it's accepted by people. And I'd like to end there.